Hello, I'm Joseph. This is the Raspberry Pi Pico W. I've already shown this in my part one, but just a quick recap. It is a microprocessor, an M0 plus ARM Cortex processor running at 133 megahertz. It has 256 kilobytes of RAM and 2 megabytes of flash storage. This is the W variant. It has the Wi-Fi chip right there. It's a 2.4 gigahertz Wi-Fi module. So that was just make sure you understand that part. Um, it gives me 80 requests a second or higher for just serving some raw HTML stuff. And even while it's being requested, which is what you see here, I can actually still get a response back from the web server, which I thought was also really cool. So this is jumping down. I'm not sure what's going on with my Wi-Fi now, but it's gone anywhere between 100 all the way up, and I'm not sure why there's a higher rate. Anyways, I'm gonna stop that for now, so I can keep running this. I have the basic start of it, so I can do like some stuff here and get some information about it. You see, it's really quick in that response, but obviously it's because it's running localhost, and I can get all the different little errors there. So very simple in that regard. It's only designed to show like one error at a time. I probably need to change it to include multiple types of errors at once. This way, if I don't include any of this stuff, I get all the errors back rather than just one. But anyways, doesn't really matter. Um, Couple things I've done here, just for some context though. There is a library called PicoServe that can work in what I'm doing here. But the Pico supports here, this thing supports C or C++ and MicroPython out of the box with the Pico SDK. I am not using any of those. I am using Rust. With Rust, you can use something like Embassy. Embassy is a asynchronous platform you can build on top of. They also give you a TCP server. In Rust, you can use PicoServe. I didn't use it because I didn't know it existed, and I've already built out more than what PicoServe has to offer. So it doesn't fit me anymore to even bother with it. But this is for some context because the C, C++, and MicroPython all have web servers you can work with. You don't have to do exactly what I've done. So I've built out a web server on top of the TCP server, TCP connection. And so here I have a request and a response. Why I'm using Rust? Because why not? I thought it was pretty cool. I was getting a lot of throughput on my Raspberry Pi 02W, like 2,500 requests a second, using all cores. So I want to hopefully be able to emulate that performance in Rust, which it seemed to already do because I can get, like I said, that 80 requests a second. Couple things in Rust that I really like. One is you just like in C or C++, you don't have access to the standard library and you don't have access to dynamic memory. So you have to predefine everything. So for example, the header keys are 32 bytes max length. If it's longer than that, it's going to get truncated. Same thing with the values. So if you have a cookie that's longer than 128 bytes, it's not going to be able to store it. But if you needed to change it, you don't need to be going to these constants and changing them. You can just pass in, 256 instead. So I thought that was really cool in that regard. That is a double-edged sword though. So right now, with all my features I have in place, I have 280 kilobytes, and I only have 2 megabytes of total flash storage to work with. And I'm sure even then, some of that's used in for some other stuff. It's not just for the binary run size. So by doing something like this, which is called static generics, you're bolstering the size of your binary, and every time you add in a new custom size, you're obviously going to increase the size of your binary. Um, so that's something I need to balance with my application. So for example, I do have a template engine. It's very basic, very rudimentary, as if and else support, as well as being able to do user replacement. I'm working on a for loop. I don't have that quite figured out just yet. Um, when I included the template engine, it was at 1024 kilobytes or 1024 bytes max length. It added 80 kilobytes. 100 lines of code added 80 kilobytes to my runtime. And then I need to add in a custom length. So when I go to my sign up here, my sign up post, and I want to deal with the if and else or whatever else, I needed to change this here. This was 1024 to a static generic. When I did it, I added an additional 20 kilobytes. So 100 megabytes now just to run a simple, you know, less 100 uh, 100 lines of Rust, adding 100 kilobytes of storage, or I guess disk utility, to my runtime. So yeah, just it's really cool, but it's also a double-edged sword. Another thing here I want to point out is that you can do some really cool pattern matching in Rust, just like you can do in many other languages. But for example, I'm unwrapping user password, password two. If they're all unwrapped, they have something provided and it matches both passwords. Then I go ahead and insert a user database record. This is a simple key value that I've created. I don't have it writing to disk just yet, but I am working on that along with the template engine, like I just said. So yeah, all very basic rudimentary stuff here. Another thing I like in Rust, but it is also something that caused me some grief, is having to do, actually it's in main here, having to do with being able to include a file as if it was actual a string in your Rust application. This is actually in C++ 2023. Um, but this is also a double-edged sword in that while you can include any sized file that you want, when you're passing it to another string or byte array, it also needs to fit. So if you do an as bytes and you append to it or something like that, or you do from slice, um, it's a problem. So for example, if this was like 24 kilobytes and I go to write to my body is set to 16 kilobytes. There will be no run or compile time error saying, hey, you are trying to include this into something that doesn't fit. It will actually do a cause a kernel panic on the Pico and it will lock up. So I had to do a little bit of a change. I wrote a macro on top of a macro, and so now I can pass in the actual length I'm expecting it to hit. If it goes beyond that, I will get a compile time error. So that was nice. But me using Rust lets me kind of forgo a debugger, at least for now. But having to know this issue, I had to like comment out, and I had to masterfully penetrate the USB-C port over and over every single time for every single line I was enabling disabling because I don't have any way to do a console log or any type of step through debugging because I don't have a debugger with me just yet. I will get that later this week or actually next week. Hopefully that will cause some grief to go away. So all that said, that's the Pico. That's my update. I have a template engine. I have a database. I have a web server, and they all seem to work. In terms of my to-do list, I have to finish up multi-part parsing. This way I can do file uploads and more complex post data submissions because this is going through that. The last thing I want, oh, and then I also need to finish up the for loop for my templates. And then the last part, this part is probably not important to you. I had to decide on my web application whether I was going to go the JSON route. So I serve the JSON and I have a complex React, Vue, Angular, Svelte, Solid, whatever framework on and consume it. The catch is that means every single JSON response I need a Rust structure for because I need to be able to serialize it and deserialize it. That is going to cause a bolster in the size of the binary runtime. Even if I try to do static generics for like a standard response, it will still, every time I make a new custom size, cause another additional, kilobytes worth of to my binary. I was like, okay, well, what if I just do like raw serialization? Raw serialization, no different. Still need a bunch of structs for everything. If I do HTML, I want to do HTML. In order for HTML just to respond back, I need a template engine because if not, I need to do all this custom logic to this template engine to my code. If I try to do that, every if and else and for loop or whatever else that it's just gonna keep adding to my binary size. So what I settled on is kind of what you'll see here is HTMX. HTMX is not new, not really a new concept either, because I know in Laravel there's like Livewire and stuff that I used prior. Um, it lets me get the best of both worlds. So I have a very simple template engine that you saw there, the if, else, and replacements. And then I can use that and just serve back HTML and sometimes some JavaScript if I need to, and forego having to need to off or unload all this HTML in my binary. Obviously, I have an SD card. Um, this here, this will be all these templates, all the HTML templates will live on the SD card, but the logic for itself, all these simple engines will live on my binary. And so rather than having all these structs and everything else, I can just have a finite set of logic that I'll know that, okay, well, I can't do a big for loop because it's going to add, 5 additional kilobytes. So let me think about another way to do this here. But I can gauge that. I can gauge that more than I would be able to gauge adding more JSON with generic static generics and doing all their stuff for serialization, deserialization. So it saves hopefully compute time on the Raspberry Pi, and I get a very performant web application without having to even write very much HTML and JavaScript. So for example here, all this stuff is doing an AJAX response. It's replacing it with HTMX, and the HTMX response is really, really rudimentary. So if I go ahead and put in an email and I go to the network response and go to sign up, look at the payload, here's the payload. So very, very simple in that regard. Obviously, I kind of need to fix this null buffer here. Probably doesn't need to send uh, all 4,000 kilobytes of empty data, but yeah, kind of get the idea.